Assembly lines are beautiful but quite complex systems. Materials are going in and out everywhere. Workstations are going at different paces. Inventories are continually going up and down. Individual components of the system have dependencies between each other. A small disturbance at one of them may have a big impact on the system as a whole. And that's not even the whole picture. To have a complete understanding of how an assembly line is doing under real production conditions, we must take into account even more parameters. We must anticipate machine downtimes. Machines may stop or break down at a different point in time for various reasons, and repair may take more time than expected. Even if a workstation is only experiencing small stops, the disturbance could propagate to upstream or downstream workstations over time. We must also consider the process variability. Some proportion of defects might be generated at some places. Are defects immediately detected and eliminated? Or, are they continuing their way down the line until a sorting station is able to dump them? This may have a completely different influence on the line. Both the position and the proportion of defects have an influence on the performances of the assembly line. Also, we might have to manufacture a different product mix with this assembly line eventually. This different product mix may require different materials and operations to be properly manufactured. We need to make sure the assembly line is also able to adapt to these conditions. Furthermore, some additional time may be required to make a complete changeover on the line to start manufacturing the new product mix. As you may have guessed, all those parameters must be taken into consideration to determine the actual throughput of the line. This doesn't seem an easy calculation, does it? Simulators are here to help you for that specific reason. Using assembly line simulation, you will be able to build a digital model that reflects the behavior of a real assembly line. By testing different scenarios, you see how the assembly line behaves even before it has been built. By changing the parameters, you will understand the influence of those parameters on the system as a whole. If a specific machine goes down for half an hour, does it have any significant impact on production volume of the line at the end of the day? If a process drifts and starts generating defects, how many defects will be produced until the issue has been detected and resolved? Do we have enough time to manufacture 2 types of product a day, with a complete changeover of the line in between? Simulation answers all these questions. With simulation, the assembly line becomes predictable. From a business perspective, predictability is a must-have to guarantee the client will be delivered in time. It gives insurance to both the manufacturer and the client. Predictability is also a benefit for employees that are working on the assembly line. It gives them confidence that the system they are working on is able to meet their expectations, it appeases the working environment and releases stress. On a final note, assembly line simulation can definitely help to improve the throughput of a line, to shorten the lead time or to reduce inventory. This is what most people put ahead when talking about it. But more importantly, it gives confidence on the production line. It gives the possibility to both employees and clients to work serenely and to be satisfied in their job. I hope I gave you a good overview of how assembly line simulation is used in the industry. If you like this video, please like and subscribe to the channel to view more videos like this in the future. Consider leaving a comment, it helps with the YouTube algorithm and I will answer when possible. Visit Visufact.com to learn more about assembly line simulation. Visufact is a simulation software that is currently under development. You can try the online demo and subscribe for beta that will come out later this year. Thanks for watching and have a wonderful day.